Hi everyone, welcome back. Today we're going to look at decimals, changing decimals to fractions. We're going to look at Practical Maths grade 10. We're on page 6, we're going to do number 10. So question number A says 0,5 recurring. Remember we want to put a decimal into the form B over A or A over B. So we want a fraction, right? So what do we have? What we have here is a decimal. So the first thing we're going to say is let the decimal equal x, or let x equals the decimal. But what does this decimal actually mean? So we're going to keep that x and we're going to say this recurring symbol over here on the top actually means that the 5 continues for infinity. It never ends. It's 5 repeating forever. So what we want to do is we want to get a number that has got nothing behind the comma. This here, we want to get rid of it because it is going to make it very difficult to get your fraction. So we want to eliminate all those 5s. In order to do that, we are going to say that the number of recurring numbers or digits is only one digit, right? So it's 5 recurring. There's only one digit that recurs. So I'm going to multiply both sides by 10. And I'm going to say 10x is equal to, and now that I've moved my decimal, I'm going to have 5 in the front, comma, 5 repeating to infinity. So now that I have this, I am able to create a sum, right? I am going to say the larger number, basically 10x, which is equal to 5,555 repeating to infinity, minus 1x, which is equal to 0,555 repeating to infinity. It's going to give me a total. So on the one side, on the left hand side, I'm subtracting. So 10x minus 1x gives me 9x. And on the right hand side, I'm going to say 5x minus 5.555555 minus 0.555555. So now notice, this is what I wanted to get rid of. And this here allows me to get rid of it. So this cancels out with that. It becomes 0. So what I'm left with is 5 minus 0 equals 5. So in essence, 9x is equal to 5. Now in order for me to make this a fraction, I'm going to make x the subject. To do that, I'm going to divide by 9 on both sides. 9 and 9 cancel out, and I have x is equal to 5 over 9, which is my final answer. So what did we do? Your goal here is, first of all, you need to identify that you have a recurring decimal. We see that with this dot. The dot tells me that that number repeats to infinity. My next step is to write it out. So I'm going to write it out like this so I can see what I've got. And then I know that I want to get rid of everything behind the 0. So I need to get the same numbers behind the 0, and I need to move the decimal so that I have a number in front. So I know in this instance I move it one decimal place, therefore I have one digit in front. So it's going to be 10, which is one decimal place. I subtract 10 from 1. I subtract 5.5 recurring from 0.5 recurring, and my answer is going to be x equals 5 over 9. Let's try this again. So in my question, I am saying let x equal the decimal. What does this decimal mean? Now I'm going to skip a line and you will see why in a minute. I'm going to say x is equal to 0,36 recurring, right? So that means 36 repeats for infinity. I want to get rid of this. And what I see in the this that I want to get rid of is it's 2 different numbers, 2 decimal places. So I am going to multiply by 100. So I am going to say 100x is equal to, and because I moved the comma 2 places, I'm going to say it's 36, comma 363636 recurring. So now notice that these are all in line, right? 363636 recurring. So I am going to say 100x minus 1x is going to be the same as 36.363636 recurring is minus 0.363636 recurring. So in order to do that, I'm going to say 100 minus x is 99x, which is equal to 36, because this cancels out with that. Okay, so now I want to simplify. So in the end, what I want to have is x equals a fraction. So I am going to get rid of this 99 by dividing both sides by 99. So this cancels out with that, and I have x is equal to 36 over 99. But this is not the simplest form. If I divide it by 9 again, I can say that 36 is equal to 4. 4 times 9 is 36 over 11. 11 times 9 is 99. And this is my final answer in its simplest form. Okay, so I'm saying x equals 0.4 recurring. Already I can see it's one number, so I'm probably going to end up with 10x, right? Because I know it's one decimal place. Before I get there, I'm going to say x is equal to 0.444, continuing for forever. Once I've got that, I'm going to multiply both sides by 10. So I'm going to say 10x is equal to 4,444 recurring. I now know that when I subtract this side from this side, then I say 10 minus 1 is 9x. And these numbers all cancel out, so I have it equals 4. So in essence, when I divide by 9 on both sides, this and this cancels out. X is equal to 4 over 9. Final answer. In question D, I have two decimals. So x is equal to 0.29 recurring. This means that x is equal to 0.292929 dot 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 forever. 292929. In order to move my decimals, I'm going to move it 2 spaces. So I'm going to say times 100. 100x is going to be equal to 29, 292929. Now I'm going to subtract. So I'm going to say 100 minus x is 99x is equal to, this cancels out with that because 9 minus 9 is 0. 2 minus 2 is 0. 9 minus 9 is 0. 2 minus 2 is 0. 9 minus 9 is 0. 2 minus 2 is 0 for eternity. So after my decimal, I have zeros. I have a whole number. 29 minus 0 is 29. So now I need to simplify. So I divide both sides by 99 because I want x alone. Divide by 99. On the left, it cancels out. So x is equal to 29 over 99. Since the number 29 is a prime number, this is my final answer. Question E, x equals 0.7 recurring, which means x equals 0.777 until infinity. I have one decimal place, so I have 10x. 10x is equal to 7.777 until infinity. These numbers cancel out when I subtract, so everything behind the 0 cancels out. I have 7 on the right, and that equals 9x. Next, I divide by 9 to get rid of the 9 on the x. I want x alone. Divide by 9 on the other side, so x is equal to 7 over 9. Final answer. This question, I'm going to say x equals 0.32. So x is equal to 0.3232 3232 until infinity. I've got 2 decimal places, so I'm going to have 2 zeros. 100x is equal to 32,323232 until infinity. Next, I subtract on both sides. 100 minus x is 99x. 32,323232 minus 0,323232. Those cancel out. It is equal to 32. Now I am going to get rid of the 99. Divide by 99 on both sides. Those two cancel out. X is equal to 32 over 99. The next question says, let x equal 0,273. Now this line on top of 273 is the same as the dots. So this means that x is equal to 0,273, 273, 273 until infinity. I've got 3 digits behind the decimal, 1, 2, 3. So I am going to have 3 zeros on my x, 1000x. 1000x is going to equal 273, 273, 273, 273. So when I subtract on both sides, I know that that cancels out with that. So 999x is equal to 273. Now when I get rid of the value in front of the x, 999, divide by 999, and I will say that x is equal to this fraction, 273 over 999. Next up, I need to see if I can simplify. Now, in order for me to check, because these numbers are big, just on a side note, if you are checking if something is divisible by 3, what you do is you add up the numbers. So if I say 2 plus 7 plus 3 is equal to 12. 12 divided by 3 works because that's 4, which means that 273 can be divided by 3. That's the rule. If the numbers added up can be divided by 3, then the big number can be divided by 3. And obviously 999 is divisible by 3. So I'm going to divide both sides by 3 over 3. And I am going to get 91 divided by 333. So now I'm going to check again, and I'm going to say, okay, 91. If I want to check the factors of 91 using my calculator, I'm using the Casio 82ZA Plus. So I'm going to put 91 on the calculator. I press equal, then shift fact, and that gives me the factors of 91, which is 7 and 13. 7 and 13 do not go into 333, so this is my final answer. That's as simple as it gets. Last question. X equals 0,69. So I've got 2 decimal places, which means I'm going to have 100x is equal to 6969 until infinity. I said x equals 0,6969 to infinity. Next, I'm going to subtract on both sides. I'm going to say 99x is equal to 69. Next up, I divide both sides by 99. So that becomes x is equal to 69 over 99. Now remember what I said on the previous slide. If I add the numbers up and I can divide by 3, it means I can divide by 3. So 9 and 6 gives me 15. 3 goes into 15. I can divide by 3 on the top. 9 and 9 is 18. I can divide by the bottom. So I'm going to divide both numbers by 3 over 3. And that gives me 23 over 33. Now I can check again if I can divide by 3. 2 and 3 is 5. 3 does not go into 5, and therefore I cannot divide by 3. And it doesn't matter at the bottom, right? So I'm going to check for the value of the factors of 23, and 23 is a prime number. This here is my final answer. X equals 23 over 33. I hope this made sense to you. make a note of any questions that you want to ask, and we can discuss it in class. Thank you. Bye-bye.